morning, everyone. So I'm Mike from the Second Engagement team at Zenzic. Thank you for joining us on a Friday morning. I know that Fridays might be quite tricky as some people have Fridays off, others are wrapping up for the weekend. So I really appreciate you taking the time to hear from us. So as you might be aware, the team at Zenzic have been organizing our annual event, Innovators Day, in March 3 years in a row now. So every year we do our best to feature as many organizations in the CAM space as possible, showcasing the amazing successes that the CAM community have been achieving over the year. However, at Innovators Day, we probably only have around 6 to 7 hours in the day to feature everyone and to showcase all these amazing things that you're doing. So it's a big challenge. So we've been putting a lot of effort to promote various CAM projects and initiatives at various events and roundtables, discussions, and other activities. But we know that there are so many more topics to be talked about, which is why we organize this webinar for you to hear about latest developments from the industry and other stakeholders. So this is going to be a series of webinars, which means that there will be more opportunities to get involved and present your work to the CAM community. And we're starting with the topics of safety, simulation, and data. And we will have Mili, Naik, who is the technical delivery at Zenzic, who produced the UK CAM roadmap to 2035. And she will present on one of the topics of the roadmap, which is infrastructure and data services, which we just published the report for. Mili will talk all about it. And then we've got Michael Orgill, project engineer at Horiba Mira, who will talk about the level 4 assurance safety case from one of the commercializing CAM projects, Harlander. And the last presentation will be about the scalable simulation-based safety assurance framework presented by Dr. Jason Zhang, who is simulation lead at WMG, Warwick Manufacturing Group. Unfortunately, we're not all at the WMG side now, and we're not at Horiba Mira either, but I've seen that Jason and Michael have included some really great pictures and videos in their slides. So hopefully we'll all feel like we're actually there. And there will be a few minutes dedicated to a short Q&A as well. So if you could all send questions to the chat, and we'll pick them up after each presentation, and the speakers will answer them. And if there's some time left in the end, we can also have answer any last questions as well. And now over to Mili from Zenzic.
Thank you, Mike. I'm just going to share my screen. Can you just let me know if that works?
Yes, you can see it.
Perfect. Right. Good morning, everyone. Thank you for your time on a Friday morning. I'm going to be, as Mike said, I'm Mili, and I'm the technical delivery lead at Zenzic. Today, I'll be talking to you about infrastructure and data services within like the connected and automated mobility. So how does this like CAM roadmap come into picture? So what we talk about is UK CAM roadmap and the strategic research, which forms like the insight pillar at Zenzic. And this particular topic just talks about like the UK CAM roadmap to 2035, which we updated last year. And then from there, we kind of have topics that are uncovered. And we are going into depth for the first one, which is the infrastructure and data services. So how we came across it, I'll just give you a brief update about them. The first is like we talk about the why, and why do we really need CAM? What is it really? What will it enable? And from there, we get into what are the actual products, services, and solutions that we are looking into. And then finally, how and what can be really done about it? What are the key priorities and actions that are needed? So as I said, in today's topic, we'll be talking about infrastructure and data services, and which is identified as the key CAM enabler, along with verification and validation to support the 4 applications that are I mentioned at the top of the product, services and solutions. So what we've done with this roadmap or the white paper we call is we followed the same structure that we did for the overall roadmap. So we still kind of align to why, what, and how. But firstly, we're getting into why. Why do we need the data services? Why do we need infrastructure? So I kind of went through these questions in looking at it from an outward aspect. So if someone is not looking within CAM, what does it really do? What does providing data really help with? So the first one is around building that trust and confidence. We all rely on a lot of data in our day-to-day lives, and CAM will be no different. Probably it might be more relevant in our case. But building that trust and confidence is one of the key things that data can provide. Yes, the biggest challenge around them is the accuracy and reliability, but that is also covered and in the other parts of the document covering the what's and the why and the how, sorry. The second is building the UK CAM supply chain. We've seen in the, if you haven't seen it yet, but you can go and download the UK CAM supply chain. And one of the key areas that are identified is software, which is the biggest strength. And communications and infrastructure is also identified as like the biggest opportunity, which details are also in the roadmap. This actually allows us to build, provide economic and societal benefits with exporting capabilities, but also bringing in more job opportunities. And lastly, it's better connectivity for people. We in today's life are so much dependent on data and how accurate that data is, how timely can we receive information, what can really save us time, etc. So the more data we have, the more better connectivity we have for people, and puts the public and the people who are the end users at ease when certain data and infrastructure are available on time. Moving on to looking at inwards. So, sorry, that is blank. So it goes back to the same question, but it's like now, if we are looking within CAM, what is data and infrastructure really providing? So why is it needed? Why is the data needed? So first and foremost, it provides real-time decision making. The vehicles are capable of providing of driving by themselves, but there is also a lot of dependencies on other users and what the other road users are doing. So it enables it. We look at V2V and vehicle to infrastructure communication as well. Mapping and navigation. So one of the key, depending on how the vehicle is set up, what type of navigation it uses, but still there will be a requirement of some sort of mapping and navigation, which requires data. Monitoring and maintenance. In the recent year or two, we talk a lot about the maintenance side and in the long run, what needs to be done, how will it be monitored, what are the legal requirements, how will the vehicles be maintained, etc., which again is a key area for the why. Fleet management, again, if you're talking about public transport vehicles or any other sort of vehicles which uses a fleet of vehicles, then managing those and optimizing, being more efficient, and having working towards that sustainable environment as well is key. And lastly, we've got data sharing and collaboration. I think there's a crux of a lot of work that is needed is around data sharing. In the past year, I've talked to numerous people, and being able to share the data between different stakeholders, like the transportation agencies, private companies, is something that will improve overall mobility solutions, but is also one of the biggest challenges that we kind of face to enable and deploy CAM at a large scale. Moving on to the what. So kind of, there's a blurred line between the why and what, but it's just how the data is represented differently and what it really does. So in this case, like when we talk about data collection, so it's the collection data by the vehicle itself, and it's the sensors and which captures the vehicle surrounding and what's going around it, but it can also be the collection of data from a roadside infrastructure, maybe a camera that's set up on the road, or V2X units that's capturing like live data. And once this data is being collected, what it's just raw data, as someone says, just numbers. That doesn't mean anything. So there's data needs to be processed and analyzed and providing insights, which work we do as well. And then we've got communication and connectivity, how these data are going to be provided to users or to stakeholders, and the infrastructure becomes a key part of this piece of work. And then we also look into the other of like how the data will be stored. The cybersecurity is the big aspect of data when we consider having large amount of data anonymized or not, or something that needs to be shared between two different stakeholders. But data and like cybersecurity is one of the key areas. Making like decision making and control systems, maintenance and support, again, as we kind of captured in the why bits as well, but is required. And lastly, we've got in-vehicle infotainment, which there's endless possibility of interaction and entertainment when it comes to in-vehicle infotainment. But to do these, we need the infrastructure, and there are various types of network that are available, but the dependency of these are really on how quickly the data is needed, how big is the data that needs to be transferred. And so we come into that questions of low latency, of like latency and bandwidth and those questions. So what we generally see is having real-time data, which is needed to make instant decisions, or they are safety reliable, safety critical data, and those really need like low latency and like high bandwidth. They need to get through. They are not necessarily, everything doesn't fit into the same, like everything that is a batch data is not necessarily low bandwidth, but there are more these are general kind of way that we see what the data and how quickly they need to be transferred. So with the real-time data, it's the, like, for example, the safety critical data. With the near real time, I think this is a big question on what is really real time. But it's like when we look at examples of communicating information between like vehicle and the control center, there is a lot of discussion around having remote operation or remote monitoring, and these are real-time data, and the near real-time data is something very crucial. Passive data, we talk about in-vehicle entertainment, not necessary, but it will definitely be a big value when we come into the deployments of CAM. And then lastly is like one-time irregular batch data that has been processed at later stages, but also software updates and those sort of data which might be done, may not be done on the move, but might be done after while the vehicle is at stop. So all of these will determine what type of network. So it could be 5G, 6G, it could be just a V2V or V2X, or it could be just a local area network that's connected within the control center itself. But one of the key factors is around the latency and the bandwidth that will determine it. Lastly, getting into how, probably running slightly short on time, so I will go through these slightly quickly. But so what we've done is identified the key categories of the how, and this is where you can go onto the website. The white paper is now published and is available, so you can have a broader look of what really encompasses it and how does the timeline really look for these different categories that are identified. They again align with the whys and the whats that have been discussed so far. the one that wasn't discussed directly is around the skills and education, and having the skills, and how do we not just the operational skills but also the data analysis and processing skills, how do we get there? That is one of the key roadmap items as well. Before kind of coming to the conclusion, like the how is in the long term of how we actually get there, but what are the immediate actions? What do we think are the key priorities? So we, again, similar to our the roadmap to 2035, we've identified the key priorities for CAM infrastructure and data services as well. The first one, and this to me is, I think, one of the first things that needs to be done to even enable the other priorities, is identifying the use cases and stakeholders for the data packages. When I say data packages, is like from the work that we did in the previous year, the workshops that we had, and the conversations that have been ongoing for many years now, is around sharing the data and like what data is needed. And everyone might need different types of data. So identifying the use cases and maybe having data packages between two different stakeholders, or like, and what might be their requirements, versus seeing that as a big problem, trying to chunk it down into sizable ones. So identifying use cases and stakeholders, to me, is like the key to enable a lot of the things and under the infrastructure and data in CAM. The next is around creation of data standards and data sharing frameworks. Obviously, there's a lot of work that's already ongoing with the legislations and regulations, but these having standardized formats is something which would be needed in the long run, but also to harmonize with the European and like the world. I really see that as an example is where the mobile phones, they all have, and the network that we use, they all have their own IP and the way they manage it, but at the base level, they still follow like the similar standards, which is kind of needed for CAM. They cover like the national plan coverage, the infrastructure, National Infrastructure Commission have been doing a lot of work, and they recently released document for like your comments as well, so do go into those. But there is also a big, like there's a lot more into it as well, which needs to be done. The CAM inclusion in the National Digital Twin Program, if you haven't heard about it, maybe again have a look. I'm just conscious of the time now, might be running. So a couple of other things is around the standardization and maintaining HD maps, if that is the way an automated vehicle is using. Currently, they are being developed by OEMs or whoever the ADS developer might be. But in the long run, is that something that is sustainable, or do we need a different approach? How are we going to look into it? And at Zenzic, we don't talk about anything if it's not about collaboration. So collaboration with different stakeholder groups is key, even when it comes to infrastructure and data. And lastly, identifying the gap in skills. Yes, we do know there is need for data processing and analysis. And if you really want to build on that UK CAM supply chain, the first step is to get and identify those gaps in the skills. That is all from me today. But if you've got any questions, or if you do want to contact later on as well, please do. And as I said, the website, the document is now live, so you can go and download, and probably we'll share the link here as well sometime soon. Thank you.
Thanks, Mili. Yeah, Tim already shared the link in the chat, so you can all have a look at that. And also we had one question about the next timescales for producing roadmaps for other topics of the roadmap, but Francis has already answered the question, and we'll be publishing one on validation, verification, and assurance in the next couple of months. So you'll definitely be notified about this. We might have some time at the end just to cover a few more questions in the end. But for the moment, let's move on to Michael Orgill from Horiba Mira. I'll let him introduce himself and share his screen.
Thanks for that, Mike. Let me get the screen share going.
Thank you.
Okay, can everyone see that?
Yeah, we can see it.
Yes, good. Okay, so yes, lots to get through, not a huge amount of time, so I'll get straight into it. But today I'm going to be speaking about Project Harlander, which, as Mike introduced, is one of the commercialising CAM projects with Innovate UK. So, very short agenda. I'm going to really quickly introduce me and the project, just as much as we need to then get into the main weeds of the presentation, which are about Horiba Mira's SAE Level 4 safety case life cycle. And in particular, I'm going to talk about the in-person route review that we did in person in Belfast. We got on a plane. Seems crazy in the post-COVID world to go and see something in person, but we did, and that was fantastic. And then I'll speak a little bit about the testing and the V&V. Okay, so really quickly about me, I did a theoretical physics MSci at Birmingham, and ever since I've been working with Horiba Mira's CAB team. So this is my sort of lifeblood at the moment. I've worked with US and Southeast Asian startups, a lot of the European OEMs. In particular, I'm doing a lot of work at the moment in the construction and mining industries. But the thrust of today is about the Innovate UK consortia. So I've in the past worked on sort of Vivid, VeriCav, if these are project names people recognise. But today we're talking about Harlander, of course. So Project Harlander, what is it for anyone who doesn't know? Very high level terms. It's an attended trial of a level 4 ADS around part of the Belfast Harbour estate. That's of course in Northern Ireland. It's about a 2 kilometre long route to and from the train station, essentially, via big industrial complexes, the local college, and some tourist locations like the Titanic Museum, the Titanic Hotel, and the Giants ice hockey stadium, which I didn't know was there till we went. It's quite an impressive bit of infrastructure. So we can see that we're addressing commuters, students, and tourists there. The people providing the ADS are Oxa. I've highlighted them in the bottom right. And the company providing the electric vehicle bus platform is Eversum. Horiba Mira, of course, are doing the level 4 safety case. The important thing to stress here is that the trial doesn't happen until Q1 2025. We're only halfway through the project. So I'm going to tell you today about where we're up to, but the project is not finished. There is not yet a level 4 vehicle on the road. We need to be very clear about that. That's exactly as planned. No one intended there to be one yet, but this is a sort of stake in the ground about 50% of the way through the project. I left this slide up to talk about level 4 versus the other levels, but I don't think there's time, so let's press on. So let's look straight into Horiba Mira's SAE Level 4 safety case lifecycle. This is it's a simplified version of our worldview for how the flow here might work. So bringing up this top line, the important thing to call out is that we've tried to make this agnostic to whether you have a specific route in mind or a more generic route. Often you might delineate that between whether you define sort of an ODD or a TOD, target operating domain. In the case of Harlander, we're very much in the TOD regime. There's a very specific route. It's 2 kilometres long. It's in Belfast. You can go and see it. We're not talking about motorways in general. We're talking about very specific roads or so on and so forth. Broadly, the life cycle is cut into 3 or 4 parts, which I've separated by when the big testing phases happen. So you can see on screen, I probably don't have time to talk through every box in detail, but you're all very capable people. And so you can have a quick read. This first part all builds up to proving ground risk assessment. So this is obviously not on public roads, facilities such as Horiba Mira's Assured CAV, but also others. And then we get to the first phase of testing in simulation and on the proving ground. Obviously quite a low barrier to entry there ultimately, because it's a proving ground, so we can control the risk quite simply. Once we've done that, we get a huge amount of information, and then we see that going into essentially what we would call a level 2 safety case. This is an interim safety case, of course. So it's getting us to the point where we can trial on a public road with a safety operator, sort of the bridge going from proving ground to public roads. This is perhaps the big exciting curve where we go to a level 4 safety case and can ultimately go and do testing and trialing without a safety operator. And then if all that goes well, of course, you still have to maintain your safety case once you've deployed. It doesn't stop the day you deploy the vehicle and cut a big ribbon and say that's it, one and done. It's a continuing, evolving process. And in fact, we anticipate at Horiba Mira that some of the most interesting data you get will be post-deployment. You know, even all the testing in the world beforehand isn't going to quite be the same as deploying in real life. And I think empirically, a lot of people know this in their gut, because a lot of people would agree you learn to drive after you pass your test, for example, in a human case, right? That sure, we can pass the test, but it's when you take someone out of the car in your first few weeks afterwards that you maybe really learn. The analogy for an AV is that that's when you start in a completely uncontrolled environment, and the public around you start to get used to you, so they stop giving you such a wide berth, and they start driving around you a bit more normally. Normally includes aggressively, incorrectly at times. There was a lot of information on that slide, so hopefully it was, you know, pictorial enough just to give you a sense of the flow. We could always come back to that, or I can answer questions offline later. One of the big things I want to dig into is what we did in February, which was the in-person route review. So we sent 3 engineers out to Belfast, and we reviewed the route by car and also on foot. And hopefully this is one of the more exciting bits of the presentation, because I'm going to show some of the really interesting things we found. Before I start, what I want to stress is you might think, oh, you could do a lot of this from satellite imagery, from pictures, from Street View and other equivalent services. We thought that too before we went. We were, you know, one of the things we went to try and understand is how valuable is this exercise? Do we get not much information for quite a lot of time and effort? Could we have done 95% of the learning remotely? The answer is an emphatic no, but let's see why. So I picked out just a few of the things we observed, which are unique to this route in Belfast and this TOD. So, for example, there's a very wide lane that is on the route, and these cars you can see are all in a lane that the AV will eventually use. The locals think the lane is so wide that you can just drive 2 abreast. It's not 2 lanes, it's 1 lane. There's no sort of rhyme or reason to when people do this. This is quite an unusual behavior that the AV would have to deal with. We can add this functional scenario to our test program. Cyclists, it's good to just observe some real attire. That's going to inform our logical scenario parameters when we actually come to that point in the testing in September time. And we can add that to our TOD. Again, for example, if I go back one, actually, we had cyclists in that bottom image cycling 2 abreast. One of them was outside of the cycle lane in the path of the AV, potentially. Here, this was at rush hour. We had a lot of cars queuing out onto the road, so that I think it's a Polo at the back there in the black in the top image is sat completely in the middle of the lane that the AV needs to use. It would have to either stop or overtake. If it stops, is that more obstructive and the locals start sort of bombing around it? You've got to think about these sorts of things. This was an interesting observation. The bottom left image in particular was really fascinating, because the gap in between those 2 parked taxis is where the AV has to park to get people on and off. So that's a particularly challenging scenario, we considered it to be anyway, because you've got to pull around a parked vehicle that's on double yellows and in a cycle lane, parked, alight and let people on, and then you've got to pull around another taxi that's also illegally parked. So there's an argument perhaps that these behaviors disappear once the AV is actually deployed, but nevertheless we need to observe this and add it to our test program in the short term. Here's a few more examples of parked vehicles. The main thing I wanted to call out here is that there's a big Amazon depot at the top of the route. So at certain times of the day, you've got like 50 Amazon vans coming out. That's, again, quite a unique aspect. Really important to differentiate between the ODD and the TOD there, because you're never going to think, oh, yes, let's plan for 50 Amazon vans in one big glut, whereas that's actually quite a regular occurrence on this particular route. So it's all about these factors that are really specific and really local. Here's an assortment of large parked vehicles. Again, most of them, no, actually, that's unfair. Some of them are legally, some of them legally. You've got to remember that Belfast is a port. You know, that's why it's called Belfast Harbour. So there's a lot of industry, business, heavy goods, etc., going on, being moved around between boats, lorries, etc. They're often blocking the bus lane. That's where the AV will drive, by the way, in that left lane. So we've added this to the test program. Some interesting, unique vehicles, including the police. We found that the locals drove very differently around some of these. Sorry, I skipped over that there. So yeah, one of the key things here wasn't so much how does this affect the AV, it was how does the behavior of other actors change in the vicinities of these unusual vehicles? Was there anything that, again, needs to be a functional scenario in the test program? Regular undertaking in the bus lane. This happened more than we might have expected. Again, you'd never have learned that from Street View. We've added it to the test program. And of course, that blinding one that I've blanked his plate, and the lucky person was an Audi. Could only have been less surprising if it was a BMW, in my opinion. But I'm being tongue-in-cheek, of course. So yeah, I'm probably conscious of time, so let's press through the rest of these quite quickly. Late and abandoned pulling out. Good to get some real life data on that. Pedestrians, there's a college that I mentioned right at the top of the talk. The regularly large groups of people completely cross the road, nowhere near an actual crossing point. So those people highlighted in red, that's right in the middle of the lane where the AV needs to go. It's not a designating crossing point. You've clearly got to be able to detect many pedestrians at once, not just individuals. Again, these are going to inform logical scenario parameters, the sorts of clothes that are being worn, the sorts of pedestrian densities that are being observed. You know, often you might think, oh yeah, let's test, you can see 1, 2, 3. Well, you need to be able to spot 20 at once, it turns out, on this route. And there were also, again, because it's a real port, living, breathing port, there's often heavy goods vehicles that are completely obstructing the lane or partially obstructing the lane that the AV needs to use. Again, I've put some red lines in here just to try and show the center of the road to show the overlap, or the horizontal extent to show how wide and long these vehicles are. Some of them are quite low resolution because we've taken them from video. A few last things from the route assessment. You might think that infrastructure is the one thing you can get from a street view because it's sort of static, but even there we found some things that we hadn't picked up when we did the exercise remotely before the visit. So for example, faded road signs, that's not just a little bit faded. That example on the left is completely faded. One might argue it's not actually a legally enforceable speed sign, not for me to judge, but that's a fantastic example. And here we found some occluded traffic lights where the shroud is partly blocked by a lamp pole. The other thing I was going to say on this slide actually is I don't really have any photos of it, but while we were out there, we did have a meeting with Belfast Harbour Police. I don't have time to get into it, but they have a local police force just for the harbour. And that was actually one of the most highly valuable parts of the whole trip that we didn't really anticipate before we went. So we tried to engage them on how we can start to educate locals about the EV deployment that's coming up in advance so that we can try and mitigate some of these things we observed on the route before the deployment, and take an education rather than enforcement route, which suits everyone, including the police. This one was fantastic, and I wish I could show the whole video, but while we were driving at one point, a guy on a zebra crossing decided to basically attack the car. This could happen to the EV. I've dubbed him the zebra crossing boogeyman. But the point is, this was quite a fascinating observation. You think, oh, we're only going to see like a few hours of driving, which in the grand scheme of things is not very much, is it? We're sort of only getting the tip of the iceberg. Pardon the pun. The Titanic was built in Belfast, of course. But yeah, this was a very odd behaviour that was fantastic to observe as an edge case, a corner case. Okay, I've lost track of how I'm doing for time. I think I'm probably quite tight for time. So let's press past that slide. Of course, all of this builds up into, and I've tried to stress that along the way, things we put into the test program. And then we take a scenario-based testing approach, which I hope most people on the line will be familiar with. The analogy we use quite a lot is battleships, where you have a very large, highly dimensional parameter space. In the game of battleships, you don't know where your opponent's ships are, so you fire a shot and they tell you if you hit. And we take a similar approach when we're doing what we sometimes call fuzzing or search-based optimization in scenario-based testing, where we'll do an initial sample, and then when we find interesting or corner cases, this can be sort of explorative in a SOTIF Area 3 style way for anyone that knows the standard. We can also be more targeted and directly reproduce things we observed from the route. For the purpose of the Harlander project, we're taking a depth over breadth approach, conscious of the amount of budget there is and access to the real vehicle. So we're only going to exercise in real depth 2 use cases, which are overtaking a cyclist and navigating through traffic light intersections. So what I mean by that is the final level 4 safety case we produce will not be a full safety case, but it will be a full safety case for those 2 use cases. The project itself is an attended level 4 trial, so our safety case is sort of a hypothetical thing in that sense, but post the end of the project may well come in to be expanded to include all use cases and then sort of form the backbone. So it's very much a example of how we can do this, and we think lots of people have sort of tried to go down this route. but I think get caught out by the scale of it. So we've been really narrow and focused, so we can go really all the way to the end, A to Z in our safety case. I don't think I have time to talk about that slide. One of the nice principles I did want to highlight was that we're trying to extrapolate the SOTIF principles. So for anyone that doesn't know SOTIF, that's safety of the intended functionality. It's all about how safe is the vehicle operation, even when everything is behaving as intended. So we're not in a sort of functional safety space where something's broken or defective. You've designed the vehicle exactly as you intended, but oh, you forgot to think about something, or oh, the resolution on your camera wasn't high enough, etc., etc. So yeah, we've expanded that at a Horiba Mira to include POTIF, COTIF, YOTIF. I don't know how you're supposed to say the last one. So other metrics like performance, comfort, and efficiency. And Harlander is looking at the safety case that covers that top bit highlighted in green. The last thing I want to really highlight on this slide, again, don't have time to talk through the whole thing, is two things. First, at the end, we're taking a statistical approach to try and quantify the residual risk at the end of the test program. Again, that will be only for the two use cases of cyclist overtaking and traffic lights. But the reason we've gone for that depth approach is that we can really get all the way to the end and start trying to ascribe residual risk that's been quantified with a statistical sort of system and framework behind it that underpins it all. The other thing I was going to highlight here, because this is, of course, also a data webinar, is that for the simulation exercises, we've agreed with Oxford to use BSI Flex 1889 to exchange the scenarios, which is a flex that we were aware of, but we've never used in anger before. So this is something new and novel that the project is doing in that sense. Okay, I've slightly lost track of how over I am, hopefully not too horrifically. And so, yes, if there is any time for questions, comments, that's me. Sorry, it was quite rushed at times, but yeah, hopefully fast-paced, exciting, and gives you just a little insight into what the project's doing at the moment. There's no particular conclusion, but I make no apologies for that, to be honest, because the project is only halfway through. So we are very much not at a conclusive point yet, but I've given you a good insight into the route review and some of the sort of workflows from the level 4 safety case. We've got lots of templates and structures that are sort of coming out of the project that are starting to make concrete a lot of things that have been just theory for many years now. So yeah, that's me. Thanks very much for listening.
Thanks, Michael. It was really great. I think for everyone to hear an update on Harlander and how it's going as well. So that was really useful. There was one question in the chat which I think Francis has already answered, but I just wanted to add to that. So Zenzic team have been closely engaged with ELCRIC, local Council of Roads Innovation Group. So we're delivering a series of webinars with ELCRIC to inform local authorities about what the current deployment projects are, where the areas of collaboration are, and things like that. So we're hoping that the next focus of the next webinar might be related to infrastructure and data as well. So we'll inform you about this, Richard. And also, we're also working with the National Infrastructure Commission, and they've been commissioned by the government to conduct a 12-month study about CAM, and it briefly focuses on what the main benefits and challenges to delivering CAM are, what do we need, what we should be doing, and what the infrastructure is needed to make CAM successful. So we've made sure that the views and experience of both ELCRIC and their members and various local authorities from the projects are represented in these discussions and in their study as well. But as Francis said in the chat, we're happy to talk about this in more detail. Definitely. I think, yeah, Tim is saying that we're going to circulate the slides afterwards. So conscious of time, I think we should move on to Jason Zhang from Warwick Manufacturing Group.
Yeah, thank you very much, Michael.
Thanks, Jason.
I'm just getting my screen ready for this. Yeah, it's good. A lot of the things that Michael from Mira just presented actually leads quite well into my part of the presentation as well. Yeah, so actually My topic on today is scalable simulation-based safety assurance framework. So what you just saw in terms of the parameter space exploitation as presented by Michael actually fits into one of the components into there. So my name is Zhang, or you can also call me Jason. I think many of you might have known me by Jason. So I'm the principal engineer in the VMV team leading the simulation activities at WMG. So today I'm going to talk you through some of the simulation work we have done at the WMG. So it is quite well acknowledged within the industry, and that the scenario is a key aspect of the VMV process, but also you need a execution environment. It can be simulation, or it can be hybrid testing, test track, or in a public road, but you need a environment for the scenario to be executed. And then you need to collect a set of evidence to argue for their safety. So basically, these are the very high level, the three main blocks for the safety assurance, scenario-based safety assurance process. And where does simulation sit in? Simulation actually is one of the key components within this environment part. Not the only environment, but it's a very key part. And the simulation also needs to actually consider the interface to the scenario and also the interface to this safety evidence part. So really these three main areas summarize pretty much our smaller group, the simulation activity, the simulation sub-team within the VMV team, what we are doing. And if you expand such environment, so as I mentioned, you can have environment range all the way through digital world simulation. So this, for example, a pure virtual simulation can be purely based on desktop, or you can have a simulated environment. So in the last slides, I will show you a little bit of our driving simulator where you can have X in the loop. So it can be vehicle in the loop, human in the loop, hardware in the loop, simulated environment. And then we also have, for example, Mira or other test bed. You can have test controlled environment. And then you also have the real world trials that the MFM provide such opportunity for you to actually conduct some of the real world trials. So we really have a set of environment, a wide range of environment to choose, and going from virtual to real world, but also each part of this on this vertical axis has their own pros and cons. So really we want to utilize all the simulation, all the environment, including the simulation environment, to provide a very comprehensive safety evidence. And simulation specifically actually focus on both the hybrid simulation environment, but also the pure virtual world. So I think I might also have some time limitation issue, but I will try to go through the next technical slides as fast as I can. So at the overview, this is basically within the simulation team at the VMV team. We have summarized that for a few key components in order to construct a simulation for VMV for scenario-based testing. So at the bottom, you have the scenario interface as indicated by the previous slides. You need an interface to a scenario because to have a good interface, but there's no scenario you can execute on it, then it's basically you just block the external interface to you. So for scenario-based testing, such interface between the simulation engine and scenario is very key. And we have been leading this initiative of the safety pool scenario database, which is open and free because WMG is part of the University of Warwick. So we are a non-commercialized organization. So we encourage everyone to exchange and share scenarios. And so in our simulation framework, our scenario actually has a direct interface to the safety pool scenario database. So the idea is from the simulation engine, you can retrieve a set of scenarios across different abstraction levels. So Michael just mentioned about this Flex 1889, which is a natural language-based scenario distribution format, which is very easy for people to actually read about and then, speak with each other to exchange scenarios at the human understanding level. But also we realize for the testing, you also need, for example, this parameter space to be defined, and also further you need to actually concretize this parameter range. So from the safety pool during this scenario interface, Here is a scenario interface. We actually provide all kinds of different abstraction levels, maintain coherence across those levels. So the simulation actually would take the most concrete level of format of scenarios. So the open scenario open drive, the RSN right now is called open scenario XML, no longer 1.0. So it's an XML-based format to describe scenarios. But on the other hand, to describe the behavior part of the scenario, sorry. And then you also have, on the other hand, the open drive, which is describing the road layout. So you need both this open scenario and open drive to be able to execute a complete scenario. So the simulation engine, the job is to take that and represent the scenarios simulated, but with the focus of accurate representation at the semantic level. And then, through the interface from the scenario engine to a visualization engine, for example, Unreal or Unity or any proprietary graphic engine, you can then provide a very vivid, very realistic visually and also physically in terms of physics level, what is represented, what is simulated by this simulation engine. So then, depending on which level of the SUT system on the test you are testing, if you incorporate sensor level, you can actually grab those sensor input from the visualization part. But if you are only testing, for example, the planning level, so maybe the semantic level of the simulation execution is well enough. So by semantic level, I meant, for example, the correct simulation of the road geometry, of the bounding box, the size of the car, but rather not the visual of the car, but just the correct representation of a set of ground truths. And then, so this whole three blocks on the top left side enable you to execute a scenario, but then to incorporate, to enabling the exploitation of the scenario parameter space, we need some sort of analysis engine to then grab the output from this whole simulation execution and then create more harder scenarios within our scenario parameter to enable the identification of the failure scenario. So basically, this is whole end-to-end loop from the retrieval of the scenario all the way to the identification of the failure mode of the system utilizing simulation and enable at different simulation testing levels. So could be planning, could be sensory, and could be even human in the loop. So I'm just going to show you some of the current work in progress of such work. So this is a work in progress interface that we have created just to wrap up everything represented in here from the back end, but this is the front end. So basically, the first step, you can actually, whoever have signed up to Safety Pool, you might already be given a Safety Pool API, and you can then retrieve your scenario based on API and based on your test suite. And the next tab is the create. So this actually currently related to some of the future announcement we will be making very soon. So I will keep it as a secret. So for whoever wants to actually know a little bit more, please follow us on the progress. It should be something related to this create being announced in the next month or so. But let's jump into the execute. So once you retrieve, we have a couple of ways you can actually execute the scenario. So the first way is, as I said, a scenario currently in the concrete level is described by both the open drive and open scenario. So open drive is mainly the scenery, and the open scenario is the behavior part. So open drive has the extension wording of XODR. So first we allow purely the examination or checking what is the scenery out there. So open drive, many of you might know open drive as a good description of the road geometry, but you might also be aware that open drive actually has a very good capability to describe all the other objects underneath the object tab. So what we are doing within the industry is also right now to align these objects with the object as defined in the ODD, because any ODD objects is key for the safety and the development process of the system. So in this case, we have created a XODR or OpenDrive file with a very rich object list defined. And if we generate this, so this is a screenshot of a motorway with the trees and pylons and the lamppost and the guardrail and also the road marking and grass. So everything in here, none of these are actually manually created. Everything is directly executed based on this very rich ODD-based OpenDrive file. And this is just the scope. If we zoom in, it's actually a very long motorway. I believe this example is 10 kilometers. And you can also control the next step is the time of the day, the weather, and yeah, based on the ODD description. So this allows you to fine tune to know what might be the effect. But such environmental conditions should also be described within your OpenDrive file. So if you choose not to actually fine tune this, we can then just pass directly from the open scenario and then represent in your simulation. So in this case, you can choose, for example, anywhere in the world, and you can choose a time of the day to visualize what would be the elevation angle of the sun, the effect of the sun, and also at the bottom, you can also make a slide to address across several different environmental parameters. And the next part, let's try to execute a scenario. So you can see, also we have the same naming, but now the extension is XOSC, which is the open scenario file. So for those who might not be too familiar with open scenario OpenDrive, basically within the open scenario file, you index a OpenDrive. So when you execute a open scenario, you already know what kind of OpenDrive you are using. So in this case, will be based on the same motorway, and we try to execute a scenario. And you might also notice we have 3 execution tabs. One is result analysis engine. So in this case, we basically pick the middle value of the parameter and then do one-off execution. And the other part is weight analysis engine. So in this case, at the backend, we have a optimization algorithm, which will do an iterative process to allow you to identify the system failure. And the third one, you can also combine the analysis engine to join with a system on the test. So I will show you very quickly. So this is an example. We use a very simple ALKS controller just to show you that now we're at the stage of running this scenario on the map that we just created. And I will just to jump to the next one. So this is a roundabout. And right now, this orange vehicle is simply controlled by a lane follower controller, which is very lightweight. So you might be wondering now how we can actually connect this yellow vehicle to an actual AV stack. For that one, we actually enabled the linkage to 2 of the open source simulation stack, ADS, Automated Driving System stack. One is Baidu from, one is Apollo from Baidu, that is based in China. It's an open source project. And the other is the Autoware from the Autoware Foundation, which is another open source stack. And in this case, I will show you a execution of a Autoware controlled vehicle participating the same scenario as we just shown. So on this window, before we start, we have merged the two. So in a real world setup, this Autoware will then be running in a standalone computer, whereas the simulation will then be running on another PC. Unless you have a very high performance PC, also enable the running of all these sensors, you could actually run everything in theory in one PC, but we have a distributed multi-PC network setup for this. So we merged this Autoware interface with the Unreal Engine visual. So this is showing you what a Autoware is doing when they encounter a stopping vehicle. And this is the runtime decision making by the Autoware on its own. We are simply providing the scenario and the other agent and providing the interface in this case. And I think just 2 last slides. So we also have another part. I think without going into detail, you can also select the ODD of the vehicle. And then what it allows you to do is during runtime, we will then do a ODD monitoring and tell you when your system is in or out of your ODD. So enabling you to perform downstream activity of the safety evidence part of the safety assurance framework. But in the simulation part, we provide such data. We do not do it. But in the wider VMV team, we have a sub-team to do the safety evidence, the safety team. Just to show you a couple of ODDs. So this is another virtual world, not generated based on OpenDrive. So this one is a one-to-one digital twin of our campus in the Warwick. And but also of course, if you have the open drive with the good description, we can also render this. So we can test at different ODD and with different risk aspect. And the same, sorry, let me mute it. So the same framework we also implemented in our 3XD, which is an immersive driving simulator at the WMG. So this is a 360-degree driving simulator with an actual vehicle in the middle. So what this allows you to do is actually do a lot of, for example, things like human factor aspect, how the human handover and handback can happen, but also incorporate some of the hardware of the system of the vehicle. So yeah, it's a very, very quick rush through, but based on the time, I actually removed a lot of content. But if you want to know more, feel free to reach out to me, and we're more than happy to tell you more about our simulation work. Okay, hand back to you, Michael, and maybe for some Q&A if we have time.
Thank you, Jason. That was really nice. There is one question for you in the chat, but considering the time, I think we should kind of go on to kind of close the meeting now,
Yeah.
and we can continue any discussions over email potentially. I've just asked in the chat if you could send your email address to the chat, and then we could continue some conversations over email if that's okay.
Okay, sounds good.
And I've just seen some answers from Michael as well. So yeah, thank you all. So adding on to Jason's presentation just a little bit, he covered quite a lot on verification and validation, which was really interesting. And rest assured that this is not the last time you hear about verification and validation. Zenzic will be publishing the next topic roadmap report in the next few months. And this time we'll be on verification, validation, and assurance, which Mili has been working very closely with TRL. So coming back to infrastructure as well, I just wanted to remind you that we've been in touch with CENEX organizers as well. And there's an increasing focus on CAM every year, as you know, at CENEX. And then we've been notified that they would benefit from more speaking proposals on infrastructure for CAM and data and similar topics. So just wanted to say that unfortunately the deadline for expression of interest is today, so there's not a lot of time, but if you were already considering putting a speaking proposal for CENEX, then this is your last chance to do it, and I'll send a link to the chat now as well. And yes, considering that it's 11, thank you all for joining. I think that's it from us. The meeting was recorded, so I will be sending the recording to all invitees soon. So don't worry if you missed the first part or any parts of the presentation. Yeah. Have a great weekend, everyone. Thank you.
Thank you very much.
Thank you very much, everyone.
Thanks, everybody. Bye.
Thank you. Bye.
Thanks. Bye.